Great. That was my first slide. So we're already ahead of schedule. Fantastic. Great. So what am I doing when I'm not programming? Big into TV, doing strategy, stuff. Currently trying to get to AI and ML. AI is asterisk. It's not whatever prompt engineering is, so let me just get that out of the way. Let's get into it. What's a service? Simply put, a service is a thing with a name that does something. Okay? It contains all of the resources that it needs to do that thing. By raise of hands, how many of you have heard the term microservices? Great. Next question. By raise of hands, how many people have heard the term monolith? Fantastic. Everyone. That's good. We're off to a great start. So we're going to talk about 4 areas about what makes a service well defined. I'm not going to get into the details of like performance or like runtime considerations because those are way too varied and it really depends on your context, right? So we're going to talk about 4 things today. We're going to talk about cost, we're going to talk about the concept, we're going to talk about the code at a higher level, we're talking about the controls. And these are your 4 pieces to your service definition. Right? So what is it that makes these well defined? So we're going to cost. This one's pretty straightforward approach. Your cost of services, which are your infrastructure, your integrated services costs, so like Auth0 or Stripe or Firebase, right? If you use any of those, there's a cost associated with it. You're going to be compute costs for runtime code. That could be EC2, it could be another VM, it could be, you need an 8-core processor because you're doing AI training. Storage costs for data. Storage costs are a big thing in the industry right now. It often catches people by surprise. Imagine that storage is a cost associated. But when I say cost, I'm not just talking about money, right? We also need to consider cost of system resources. So what is your memory usage? What's your disk usage? What's your compute optimized? By raising hands, who else is sick of like games being 150 gigabytes on console or PC? Yeah, raise your hand.
And wait that update.
just take the 40 gigabyte system update, that's fine. It won't crash the computer. So you need to have these costs defined and you need to have them justified. Okay? So we go to our business units or we kind of talk to ourselves as we're doing our own thing. We say, all right, well, this is how much money it's going to take to run it. This is what the system requirements are. We've justified this as X, Y, Z, and we believe that it's reasonable and awesome. Then we get into the third area of cost, which is a little bit tricky. The total cost of ownership, right? This is a lot harder to predict. So this is going to be how much time are you spending maintaining it? How much time is spent responding to outages and incidents, right? If your service is unreliable, that's a high cost. How much time is going into design or refactors or code reviews? If you have something that's very complex and takes time to kind of iterate on, that's a higher cost. Contracts and vendor management, right? If you have third-party agreements, and especially if you're working like at a larger company, it takes forever. Those of you who have had to talk to a legal or a contracts team know exactly. And then tooling costs, right? Any sort of licenses or integration that you want to consider separate across some services. Now, we talked about what makes a well-defined service. And these are going to be things that you encounter in every service, well-defined or not. You can hack something together and you're still going to have a cost associated, right? But the trick is, in this particular instance, that these are actually examined and thought about up front and not an afterthought or not just something that you are kind of dealing with as a consequence of business, right? So you're examining these and you're doing these cost modeling, and these are actually taken into consideration before you touch a line of code. So that's all we're going to say on cost. I have a little bit more at the end. But let's talk about concept. This is probably the area I feel the most passionate about because this will solve so many headaches for you before they are even a problem. So let's talk about service definition. What is it that your service actually does? And just as important, what does it not do? Right? You can't do everything. You can't do a one-size-fits-all, one-stop solution to everything, as much as your MBAs and like marketing team would like to frame it as such. You can't do that. So, when you're thinking about what you can do, what is it that's required, and how do you evaluate if things should change? At a very basic level, any function, any service is data in, data out. That can look very different across services, but at the end of the day, that's what we're all paid to do. I take this chunk of information, do something, give me information. So, great. We say, well, what does it do? What's it not? Okay, well, we're going to pull a list or sticky note and say, like, all right, these are all the things that we want to do and not do. Let's talk about service boundaries. You have an idea at the core of it, and you say, all right, this is what we're doing. How far does that extend? How far does that go? Right? What resources are you going to need to accomplish this? And subsequently, just how a service is just as important to determine what it doesn't do. No resource should exist in a vacuum. Right, so quick raise of hands. How many of you have had some weird database that just kind of sits out there that is actually load bearing, and you take it down and the whole thing crashes and no one can figure out what it is? Yeah, all right. That's a few more than I would have liked, but that's reality, right? So, so what does a boundary look like, right? In this case, right, this example, you have something's feeding into a queue. That queue is the entry point to your service. Then we have some application services that process that queue, get that compute power, and the results are stored in a database. Great, that's very well defined. You go step 1, 2, 3. Now let's say we have two different services. Two different experiences, and those API services, the power backend, communicate to a common shared database that's kind of just sitting there, right? That database exists in a vacuum. Unless you can say, this belongs to a service and this is the contract for that service, we're getting the contracts in just a second. No one's really sure who manages that database or what its access patterns are, like who really owns it. Who's responsible for justifying the cost of that database. No one's really sure, and it gets murky, right? Now, you might be asking, hey, a boundary contains all of the resources needed to run something. And in this example, these are kind of full stack applications. This also applies to software libraries, and we'll get into that in a little bit, but this is kind of general. Trying to say, hey, I need some stuff to do some stuff. So like how do I manage peer dependencies? How do I manage packages that I need? Because those packages that I need are not going to be in my system boundary, right? They are dependencies that are managed by someone else on their own system project. That's fine. Just make sure they're defined and that they are in the spot that they're supposed to be. Right, so a good example of this is you pull down a project and you go to do npm install, and it installs all of its stuff, and then you run it and it says, oh, package missing, you need this dependency. It's like, cool, that's not defined. Right? So, we kind of mentioned contracts a little bit. So, services, you should never be interacting directly with resources inside of another service, right? So going back to that example before, right, there was a database that was commonly shared. You should never be querying that database directly. You should be hitting some function, some compute that gives you a response of a defined schema. This is a contract, right? So we have data in, 5 items, goes to an order processing, data out, already, let's say authorization code, whatever, inventory, one. That way, you can change everything in here, anything from underlying infrastructure to refactor to be more performant, to more memory optimized, whatever. Nothing is going to care about that because all they care about is here's the contract in, here's what I'm bidding out. So stick to your contracts. We talked about a boundary. Your contracts are the things, what happens when they cross that boundary. Size doesn't matter, it's how you define it, right? I stole this. This is from a talk at Reinvent from the AWS principal architect. That is, he says taking the micro web services. Don't think of them as microservices, because as soon as you do, someone's going to say, cool, how do we make that as small as possible? Right? That's not the goal here. If you're going for just a minimal amount of resources, you're soon going to be managing 200 resources, and the total cost of ownership of that setup is going to skyrocket, because all of a sudden you're doing 200 deploys, 200 updates, 200 patches, right? It's awful. So you want to size with context. What makes sense is, are there going to be undifferentiated concerns like authorization, or payment, or whatever, right? So some services can actually be quite large, they're complex, and it's like a data pipeline, there's a UI in it, whatever, and that's fine. But it has to be a conscious decision, right? Define service boundary, define contracts. All right, that was a lot. We're going to come back to this towards the end. We're going to shift a little bit into code. I said we're not going to talk about runtime code because it varies greatly. It's a little bit of a lie. I'm not going to read everything on the slide because the most important things are the big letters at the top. Readable, modular, testable. And what this does is it enables you to bring new engineers up to speed much faster. It allows you to incorporate changes and switch things out much faster and more confidently. And if it's testable, you can actually written test, you can deploy and push updates a lot more confidently. Right? When you think about modular, right, everyone knows, like, cool, a function has a defined set of parameters and it's going to give you a return, right? That's a contract. So a contract can also be phrased as modularity, and you want to keep that all the way down from a function level up to a service level. All the way down. It's contracts, all the way down. Yeah, and make sure your code is human readable. Sorry, this is like a little, I'm going to get on my soapbox a little bit. Minified variable names, things that you're like, oh, this is a cool code word, we should use that. Or like, I'm going to create this new term to encapsulate like this functionality. Don't do it, please. I've dealt with enough legacy systems and enough kind of new engineers who are like bright and like starry-eyed, and it causes way more confusion than you think. Please just give them human readable names. And don't be afraid. If it's 25 characters, that's fine, as long as it makes sense. Autocomplete is your friend, exactly. Alright, so that's that. I'm not going to harp on this too much. We all kind of understand that. So here's where the second piece of the code comes in. It has to be independently deployable, right? If you have an update, let's say I'm going to go and update the UI, and I'm going to change some styles. Right? It is like the most UI thing that you can do. It doesn't interact with any other service. It is like, cool, this is what I'm doing. And you have to do more than one deploy to get it out to production. It's not independently deployable, right? If you're like, hey, I need to deploy the API service to point to a new version of the UI service, and then I have to deploy the UI service to get that new version out to the prod, and then like everything. That's not it, right? You should be able to deploy your service in isolation. Make sense? A good contract to this, like I said, more than one project deploy for one update. Not great. Here's our controls. This is where things get a little dicey, and where all of you, and pretty sure students included, are going to feel the pain. First control is maintenance. Do you have a maintenance story for your service? Do you know how you're going to roll out updates? Do you understand semantic versioning? And does everyone else on your team understand semantic versioning? Well, let me get through this and I have a little bit of a tangent. So you got to consider things like patching, and I'm not just talking about bug fixes, because bug fixes are all important. But patching, like if you're running on a VM or a server, you got to do underlying operating system. Kernel patching, you got to upgrade when they get EOL, security stuff, all that is super important. Like bug fixes and performance improvements. Someone's gonna break your shit, and you gotta like know how to profile that and get it down to, hey, it's consuming 100% of system resources and crashes, you got to figure out like how to do that. Now I call out December specifically, and this might be a little bit of a niche problem. GitHub recently released an update to one of their GitHub Actions thing, which GitHub Actions for this don't know is like automated pipelines and stuff. But there was a step that was upload artifacts, so take your code and upload it somewhere else. And they released an update that said, hey, we're not going to include hidden files by default. Hidden files in Unix is any file that starts with a period. And they didn't bump the major December. And guess what? A ton of stuff broke. People were pissed. They locked the thread on GitHub because a bunch of people were saying you guys don't understand semantic versioning. And it was a whole ordeal. Go look it up. It's a great thread. Very good. Sorry. All right. Cool. This next one's a little touchy. So a little bit of content warning. Documentation. Yeah, exactly. Listen, this is key. I hate to be that person. I harp on my engineers all the time about it too. But like, please document your stuff. Just take 30 seconds, right? Write a bullet list. Write a couple sticky notes and throw them in a README file. Literally anything is better than nothing, right? And if you're not sure where to start, here's some things to kind of consider, right? How is your code organized? How do people contribute? How can users provide feedback in terms of either bug reports or feature requests? What's the build process? How you can actually like compile and release? And what are your services prereqs? We talked about peer dependencies earlier. This is one of those things of like, hey, you have to have Node installed. You have to have XYZ before you can start running this. Document that because someone is going to come along and not know that, and it's going to be a file bug for it, say this isn't working. And then you're going to spend an hour going back and forth, and then it's like, oh yeah, you don't know like I said, it doesn't have to be fully written. And I really want to emphasize this part right here. Self-documenting code is a myth. It doesn't, I don't care, I know I was just talking about readable code, it doesn't have to be readable. Readable does not mean self-documenting. If you hear anyone say, well, the code is self-documenting, they don't know what they're talking about. They are in their own space way too much, and need some more. So please, read the conference document. Sticky note, I'll just say something. All right. This next slide I'm actually quite excited about as well. Humans. We have to consider humans, you guys. Us, engineers, users, management, and business units. Right? You have to take into account the people involved. This is a key consideration, and it's actually arguably vital to your long-term success, especially if you're just starting out or are like trying to introduce something to a new system. Right? I introduce this term kind of conscious ownership. I see a lot of this. Right? You hear about when you get into kind of professional software development, and you work especially at a large, mid to large size company. It's like, cool. What team owns this service? What team owns this application? And everyone just goes, and then it's like, all right, well now you are either have to work around that, or you have to go find the answer yourself. And that's a pain in the ass. So similarly, right, service with no owner goes nowhere. No one's maintaining it, no one's updating it, no one's making it better. So just consider your users, contributors, and maintainers are part of your service. They're part of your service definition. I don't want to say user personas, that's crummy, and I didn't really think about that. As a quick tangent to this slide, I recently worked on a project to introduce enterprise authentication into our services. This is, that's a lot of fancy words to say, hey, we're going to stick Okta in front of this login. Right? And I worked with our software architecture team, as well as some of my senior engineers. We came up with a system of, cool, we're going to have 3 Okta tenants, one for internal applications, one for external applications, and one's just going to be user and group dual replication between them, kind of is this very nice, like, we can scale up to 10,000 users, and this is going to hold, and it's going to. The team of 3 developers that I worked with on this left the company within 2 months of each other for different and very valid reasons, right? And all of a sudden, I didn't have anyone maintain this. And I had to bring in 2 devs who had 0 context, and guess what? There was no documentation for it. And the code was not self-documenting. And so it's just, it's been really painful, and we haven't used it for more than 20 users. So we designed this service that was like, we can scale all the way up to the sky. And it was complex, and we didn't take into account the humans involved in it, right? Didn't take into account the engineers, or actually who would be using it. We actually were planning for roles in the business that hadn't even been discussed anywhere else. We were like, oh yeah, eventually we're going to have like this support team. And needless to say, it's been a bit of a flop, and it's been a really big headache trying to get that through. So consider your dreams, right? If you have a small team, start small, build it in modular ways that you can build on it later. But don't just build a skyscraper, build an apartment complex. Consider future you, yeah, exactly. Do I want to build this complex in the future? No. Okay. So at this point, you're thinking, wow, Logan, this is all stuff that we hear 100 times a day around, speakers and books and best practices and whatever, and like none of this stuff is new. That's great. So if you did take something new, I'm very happy about that. If not, I understand. So let me tell you the secret. This is it. You take nothing else away from this. This is it. The secret is discipline. How many of you, and I'm kind of talking more to our senior engineering folks, how many of you can tell me what the difference is between a junior engineer who's so-so and a junior engineer who's really good at their job? Great. In a word, they're disciplined. This is arguably the hardest part about developing software, right? You have to remember all of these pieces. You have to keep them in your head. You have to think about them before you actually start building your software. Write the tests, write the documentation, include those things in your estimates, right? Always keep them in mind. So if someone says, how long is this going to take you to do? Don't just think about how long is it going to take you to code it and get the PR function. How long is it going to take you to do that? And to write the audit test, and to write the documentation. That is the estimate you do. Right? That is what the business is paying you for, is to deliver sustainable, scalable software. That's how you do it. Right? So, using nothing else, understand that what's going to make you a great engineer, a great contributor, is that discipline. It's not knowing 12 different languages. It's not knowing this framework inside and out. It is that you know to follow the steps, and you know to keep these things top of mind as you were building and defining the process. Great. Let's talk about some examples. So the first example that I have is of a software library that many of you are going to know, React. Now, it's a little time to remind you all. We're not going to talk about the runtime and the nuances of any sort of framework, right? We're talking just the definition. So React has a very clear purpose and a very clear kind of this is what it is, and that is React is a JavaScript library for building user interfaces. That clarifies what it does, and it clarifies what it doesn't do. Does React do APIs? Can you tell me what that statement? No, it's not. User. Don't get me started on WordPress. Alright, so React also has tools to do profiling, right, for performances, and like it also kind of says, here's kind of the system requirements that you need. This goes back to, hey, you have to have Node installed. I actually spent a good time finding very specific documentation pages yesterday on, cool, this is system requirements, and this is how you get started. There's documentation on both GitHub and their dedicated documentation site. Everything. There are dedicated teams at Facebook for this, you see a bug in React, you know how to contribute. You know what is expected of you, and you know the general process. It's very well timed. This is also an enterprise scale application, so set the bar really high. There's no call out, right? There are certain things around the definition that could be applicable at all levels. All right, so let's start a little more abstractly, a little more theoretical. DevOps and cloud services, right? Quick show here. How many of you have worked with cloud formation in AWS or GCPs like Orchestrator, Google, Azure? Yeah, all right. So you should be able to deploy your service, your cloud service, into any account, right? It should be regardless of what exists already. Ideally, you should contain runtime code as well as infrastructure code, and only include those resources relevant to your resource or to your service. This is also something I feel very strong about. It's been the last 5-ish years of my career, and the amount of frustrations that I hit of trying to deploy something and being like, this resource doesn't exist, and the whole deploy fails, and makes me so mad. All right. So then we go into kind of a weird third category of, okay, what if we're writing firmware? Or, I don't care whether you're doing something for Arduino or Raspberry Pi, like this would be fun to throw on GitHub. That's great. Again, document your prerequisites, which in this case are going to be hardware specs, power requirements, document what it's intended for, and what the usage is, your instructions. And I put this on this slide, this really can be applied to anything. All your instructions and documentation should be repeatable by anyone. How many of you have read a document that's like, oh yeah, this is super easy, and like you can do this 1,000 times. And you try step 2, and it's like, nope, broken. Anyway, again, define users, maintainers, just as there should be for a software product, right? Like why are you doing this? Who is this intended for? How are people going to contribute? Okay. Now, fair warning. These diagrams can be weird. All right. Let's start with this. You have your service here in the middle, and there's aspects around it. What makes it well-defined? Starting at the top of the concept, well-defined service is a clear purpose with defined contracts, make it easy to determine what changes are needed and then to actually implement those changes. Roll things out in a modular way, you're going to keep in mind your contracts, you're going to be running your tests, and it's going to be readable for easy ER reviews. Code. Well-defined service is modular, testable, and readable, independently deployable, and has adequate test coverage to release quickly with confidence. That's a quick aside. It took me about 3 years to believe in unit testing. This is something that I'm not super proud of, but I didn't know how to write a unit test. So like when I started becoming more senior engineer, and I was like, hey, can you help me actually write unit tests? And you just help me push this over the next one. It was awful. And I own that, and I got better, and I can now write automated tests. It's great. Yeah, thank you. Automated tests. Controls. A well-defined service is documented, built for its supporting team or individual, and has a defined maintenance story, making it sustainable in future growth. Last but not least, cost. A well-defined service has measured and justified costs in both system resources, actual dollar amounts, and has clear TCO, which is total cost of ownership, to determine how impactful changes will be. Last but not least, the developer of a well-defined service is disciplined and doesn't skip steps. That's it. Thank you. So it turns out I talk really fast.
We have plenty of time for questions.
Any questions? Yeah.
You talked a couple times about like total cost of ownership. Is that like a dollar amount, or is that like just describing what needed to maintain your service? Who or where would you document?
Excellent question. Everything is a dollar amount. At the risk of sounding like a business major, everything's a dollar amount. Because your time is valuable, right? So at the end of the day, especially when you are trying to determine like how much a service should cost or how much you should sell something for, right? At the end of the day, you have to determine, okay, what's the maintenance for it, what is the labor behind it. So if you're saying, all right, it takes me 4 hours to do a kernel patch on this service, and we're required to do that quarterly, so I do that 4 times a year, 16 hours, there's a dollar amount associated with that, right? Side note, if you're contracting or freelancing, take whatever you make your day job, double that, and that's your starting rate, and then hopefully you're going to crank that up a little bit. But that's your cost, right? So when you say total cost of ownership, it's like, all right, annually, if we do no features and only bug fixes, here's how long we expect to spend on it, and then you can convert that to dollar. And then you say, all right, annually for license renewal, for tools, for like expected usage, and for maintenance, this is how much it costs to maintain the open service. Does that make sense?
Yeah. So what would you document? I don't know if you're contracting, so that's part of the
Right.
pitch or whatever, but if you're, would you do this in a certain company as well?
Yeah, typically, converting hours to dollars is something as you're like growing business is a little sensitive. So typically you want to document hours, and you say, you know, when you're doing your project definition or your service definition, you're going to say, we are expected to spend X amount of hours maintaining that, and then like, here's the other things that licenses need to be renewed, here's that kind of thing. Things with that in Confluence, Google Drive, wherever you store your documentation, but you should.
So throughout this presentation, you talked a lot about, you know, like enterprise sort of deployment solutions, or deploying a project for like a larger organization. Well, what about if you are making like a smaller project that's made for a very niche community that you don't really, you know, it's not for a job or anything like that, it's just something that makes your life easier, and you don't expect people to contribute to it, but you want people to option be there. Are these also good principles to follow along with that?
Yes, excellent question. I mentioned enterprise and large businesses a lot. These apply to every level of project, right? And right here at CPOS, we want to try and, you know, really celebrate open source contributions, right? If you stumble upon an open source project that aligns with your values and your passion about, but you don't know how to contribute or set it up or run it, you can't actually contribute to that project, right? Similarly, if you're doing something around community and you're trying to like kind of say, hey, I threw this together, any feedback or features or well, whatever, you want to be able to empower those people to make it as easy as possible for you to get those projects. Right? Now, if you're just having together a project for yourself and it's something small and like maybe it's a POC or it's whatever, you're like, oh, I'll throw it up. It's kind of up to you on how serious or like how future-proof you want to make it. If it's extremely short-term, maybe you don't need to do some of these things because it's like it's just you and it's just go on for a month and then you're gonna be done. So that's fine. Just know if you decide to pick that up later in the future, you'll be dealing with that.
So I'm going to end it up tonight. How do you make it as a developer more of a developer? Try to fix the service without changing the fundamental understanding of it.
That's hard. My first response is make your documentation not hidden or surface a link that says like, if you have a contribution guide, I've seen this too, where it's like, hey, you can throw, like I've thrown a little warning that says, hey, documentation is kind of tricky, here's some like quick links, or like here's how to find it. And then I often have written my own page to surface a little more visibly of like, here's a summary and like the important bits that are important for you to know, and then here's where the more thorough documentation is. It still work, right? It's not going to be something as easy as pointing a summary here to a systems manual, but having that, putting the effort to kind of add that additional context and to kind of help them bridge that is going to be your key to success there.
I think we'll correct, like, we'll documentation. But the documentation said, yeah, it'll do 5 things.
Right, that says it. Drift is tricky. Drift is something to consider in total cost of ownership, right? So it's like, you should always budget an amount of time for bug fixes and drift. But when you find drift, and it's your service, I mean, really it's any service, but particularly if it's a service that you own, it's your responsibility to go back and fix them, right? And so a lot of times what I've found success with is if I'm working with a system whose documentation is drifted, and I don't have time to go and make all those updates, or like, I may not be the most familiar, I've actually created a work item that can take it somewhere that says specifically, go update this documentation, and here's the problems that I fixed. So it's like, as long as you're diligent about kind of staying on top of it, or making a point to come back to, that drift is not usually too painful. Don't just leave it there though. Future game.
Do you have any tools or resources that you recommend, like in terms of writing the document? Like any Google pieces on it?
Yes, I have a different talk on the whole talk on documentation, but come to me afterwards. I have a link that gives a really good tutorial on how to write documentation based off of the persona and the type that you're trying to go for. And it's like, there essentially goes down to 4 different documentation types of reference, tutorials, manuals, and account. Yes, come to me.
If you talk about independently deployable apps, so obviously sometimes you're going to have an API that's got a new rating change. How would you approach that? Would you create a separate endpoint for the rating change and deprecate the existing, or what would be the better process?
That's a good question. This is where Semper becomes your friend, right? And a lot of API design, like guides, will actually encourage you to put a version number in the URL for this exact reason. There's a few different ways to do that, but essentially if you have like a V1 and you have a contract change that is a break change, now you can deploy a V2 while all of your API clients update point to this new V2, and then you deprecate the V1 but don't use it. You can start that. But definitely you want a version. Cool. Any other questions? Cool, thanks everyone, enjoy C class.